Hello and welcome to another math video. We're going to work on 4-3 in this one, day 2. We'll do some more examples and some more practice problems. And let's see what we're starting here with example number 5. Let theta be an acute angle such that sine is equal to zero point 0.6. Find the values for cos and then also for tan using the trig identities. Let's go back here. I got the identities. So we've got sine and we want to find cos and tan. So we want an identity that relates sine and cos and maybe tan. See, sine and cosecant there, cos and secant there. That's not going to be much help. Oh, here's one. Tan is made up of sine divided by cos. That might come in useful from a quotient identity. And then here, if we have sine, we can find cos because the only other thing in there is a 1. So it looks like we're going to start with a Pythagorean identity, sine squared plus cos squared equals 1, and then we will switch to a quotient identity to find tan. So let's see here, sine squared theta plus cos squared theta is equal to 1. Now they told us that sine was equal to 0.6, so this is going to be 0.6 squared plus cos squared theta is equal to 1. And if we square 0.6, we get 0.36 plus cos squared theta is equal to 1. And let's subtract that 0.36 from both sides. Let's see, we've got $1 and we subtract 36 cents. That leaves us 64 cents. And then if that's cos squared, we want to square root both sides. The cos of theta, the square root of 0.64, is going to be 0.8. So Pythagorean identity got us to cos equal to 0.8. So here we've got sine is 0.6. That was given. We have discovered that cos is 0.8. And we saw on the previous slide that tangent is sine divided by cos. So if we want to find the tan of some angle, and we have the sine of that same angle and the cos of that same angle, we can just divide them. Well, sine in the numerator is 0.6. Denominator cos is 0.8. If you punch those buttons on your calculator and divide that, you get 0.75. 0.75. So again, we followed the directions. We found the missing things, cos and tan, using only the trig identities. Now in this one, it's similar. Let theta be a acute angle such that tan is 1/3. So I'm going to write that here. Here's our given info. Tan is 1/3. They want us to find the value of cotan. That's going to be an easy one. Let me back up here. Tan and cotan are reciprocals. So if I've got the tan, I just flip it over to get cotan. If I've got cotan, I flip it over to get tan. So the easiest one to find here is just the reciprocal. If tan is 1/3, then part A, cotan of theta, is 3/1 or 3. So we've got tan and we've got cotan. Now we need to find secant. What relates tan, cotan, and secant? Here's tan, cotan, and secant. There's the one I'm looking for. 1 plus tan squared equals secant squared. It's one of our Pythagoreans. 1 plus tan squared equals secant squared. 1 plus tan squared theta equals secant squared theta. And we're looking for secant, and we know what tan is, so we can plug in 1/3 for tan, and we're going to square that, is equal to secant squared theta. 1/3 times 1/3 is 1/9. So this is 1 plus 1/9, and we can just write that as 1 and 1/9 equals secant squared. Now it might be more useful, let's put that into an improper fraction. 1 and 1/9, well, let's see, multiply the 9 and 1 to get a 9, add the 1, so that's 10. 10/9 equals secant squared. And to get secant by itself, we are going to square root. I like to do my numerator and denominator separately. So we found the secant of theta is equal to the root of 10 over the root of 9, which is 3. So there's our secant. A couple for you to try on your own, very similar to the ones we just did. So pause the video and then try the problems and see if you got them right. All right, the first one here, we've got cos, and they're asking us to find sine. So that looks like we'll use a Pythagorean identity, and then we'll have sine and cos, and we can divide them to get tan. So sine squared theta plus cos is 0.96, and we're going to square that, and that's equal to 1. Well, if we square that 0.96, we get 0.9216. 9216. So sine squared plus that is equal to 1. And if we subtract that decimal from each side, sine squared theta equals 1 minus that decimal is 0.0784. 0784. And I was pleasantly surprised when I hit the square root key on my calculator. 0.078 square rooted gives us sine of theta is 0.28. 0.28. All right, we've got sine and we've got cos. So the tan of angle theta is equal to sine, 0.28, divided by cos, 0.96. And if we divide those, we get the tan of theta is equal to 0.2917. Now that is a little rounded. If we just kept it in the form of a fraction, it would be 7/24 or 7/24. Either answer is fine. So let's see here. Given info, tan of theta equals 2. They want the value of cotan, and that's going to be an easy one. Cotan is just the reciprocal of tan. So this is 2 over 1. Cotan will be 1 over 2, 1/2. Okay, next we're going to use again, it looks like 1 plus tan squared equals secant squared. 1 plus tan squared theta equals secant squared theta. Well, tan is just 2, so tan squared would be 2 squared, or 4. And 1 plus 4, that adds up to 5, and that's what we have equal to secant squared theta. So if we take the root of each side, we're going to get the secant of theta is the square root of 5. Okay, what's next? Number 7. Now these are interesting. We're going to do some later sections on these. I think it's in the next chapter where we're going to do these into a greater degree. But here it says use the trig identities to transform the left side into the right side. So here in part A, we've got some stuff on the left of equals, and we want it to equal 1. So the idea here is we're not going to add or subtract the same thing to both sides. We're not going to divide by anything. We're going to work on the left side until it matches the right side. Now, there's usually multiple ways to do these. Like for this first one, I'm going to leave sine alone. Sine of theta is just sine of theta. I'm going to put a 1 under it. That's not going to hurt anything. And if you look back at your reciprocal identities, this cosecant is the same as 1 over sine. All right, sine over 1 times 1 over sine. On the diagonal, we can cancel the signs to 1s. So what we're left with on the left is 1, and that's equal to the right side 1. We have fulfilled the directions. Now another way to do this, instead of leaving the sine alone, let's turn that sine theta into a 1 over cosecant theta, because those are reciprocals. And then we would leave this cosecant alone, so that's cosecant over 1, and it ends with the same result. 1 over 1 times 1 over 1, well, that's equal to 1, which is where we wanted to get to. That 1 is our finish line. Letter B. Ooh, now look at that. Yuck. Cosecant plus cotan times cosecant minus cotan equals 1. What the heck are we going to do? Since it's set up like this, let's FOIL it out. Notice it's a sum and a difference. Cosecant and cotan are the same, but we have a plus and a minus. So when we FOIL, the inners and the outers cancel. So first times first, that is cosecant squared of theta. And then we're going to have minus last times last. Cotan times cotan is cotan squared theta. How can we make that equal 1? Well, if you look back to the Pythagoreans, right here, 1 plus cotan squared equals cosecant squared. I'm going to come down here. 1 plus cotan squared equals cosecant squared. Well, look what we have. Cosecant squared minus cotan squared. Well, here's our cosecant squared, and it's positive, so I want to leave it right here. And if we subtract the cotan squared, it's going to come over here and become a minus cotan squared. Now that looks exactly like what we need. Cosecant squared minus cotan. Here's cosecant squared minus cotan. What is this equal to? 1. When we subtracted away the cotan squared, that left only the 1. So our next step would just be to write 1 equals 1. We got it. Alrighty, a couple more for you to try, and is that the end of this video? Yeah. Okay. So pause the video, try these out, start it up, and see if you got them. Okay, first one, again, we're just going to transform some stuff here. Well, let's see, tangent. If you look on your formula sheet, we could write tan as 1 over cotan, but the more useful one, tangent, is sine over cos. So I'm going to turn that tangent into a sine theta over a cos theta, and we're going to multiply that by, well, here's cosecant. What can we do with cosecant? Well, cosecant is the reciprocal of sine, 1 over sine. Okay. On the diagonal, we can cancel the signs. They'll turn into 1s. So what we're left with is 1 over cos. Now look where our finish line is. On the other side of equals is just a secant theta. We're very close. If you look at your formula sheet, 1 over cos is the reciprocal secant. So we get secant theta equals secant theta, and our job there is done. Letter B, very similar to last example, we're going to FOIL. Cosecant times cosecant is cosecant squared theta. 1 times negative 1 is minus 1. And we want to transform that to look to a cotan squared. Well, here is our formula sheet. 1 plus cotan squared equals cosecant squared. 1 plus cotan squared equals cosecant squared. Well, let's see. We've got a cosecant squared minus 1. Well, here's cosecant squared. If we bring over the 1 by subtraction, minus 1, this cosecant squared minus 1 that we have here can be replaced with a cotan squared. So cotan squared theta is equal to cotan squared theta. There we go. Look for the homework on WebAssign. Next time we're together in class, we'll do some odd problems.